I think you need to have this kind of healthy curiosity to try and explore newer fields. What is hot right now is probably not going to be hot in 5 years' time. So don't be in your comfort zones. Even if you have a self-driving car, I drove my car and I came back, right? Like, but can it also have a conversation with you? Can it also go back and cook? Can it also draw? Can it have a opinion on different topics? That's not going to happen in a while. So that's what they call as AGI, right? Like artificial general intelligence. I don't think it's near, but it feels like you're going towards that. So for some time we are safe from robots. That's my opinion.
Good morning. Okay. Acha. So today we'll do a very unique session. So computer science mein generally there are a lot of fields, like there is AI, there is ML, there is data science, there is space tech, and there is then robotics, right? How many people have ever wondered how to make a career in robotics? That's quite a few. Thoda zor se haath khada kar do. Like there's nothing to feel bad about it. It's a good thing, right? So yeah. So what we did today was that we called Naveen Sir. Naveen Sir is a founder and CTO of a robotics automation company called Ati Motors. Okay. And he'll tell what they do more about it. But this is our chance to basically, a lot of people in this room, this is going to be your first chance to learn about what robotics is, how it is important, how this field has changed over the last 5 years, what will happen over the next 5 years, and if you want to build a super successful career in robotics, like what are the steps that you need to start from today itself, right? So we'll do the session in with an objective of this, and before we start speaking, we'll just show a small glimpse of what Ati Motors does. Ati Motors is one of India's leading robotics automation companies. It is backed by some great venture capitalists like Bloom Ventures, and has a very strong reputation in the overall startup ecosystem. So before we start chatting about this, we'll play a minute's video which shows how Ati Motors products actually look like in industry. Garima? And should we turn out the lights while playing, or like is it fine? Yeah. That was great. Okay. Naveen Sir, over to you.
Thank you. So that's a slightly older video. Now we have that's the first robot that we made, and we have over 110 of them running in factories. Now we have 6 more types of robots. So something that we decided up front, I'm just going to talk a little bit about the company and then I'll come to my personal journey. Something that we decided up front is to do only specialized robots. In that sense, an inspiration is the Roomba. Have you all heard of the Roomba, the vacuum cleaner? Okay, so that's a great example of how it's
Naveen sir, for the rest of the people who don't know what Roomba is,
I will explain.
Please.
So Roomba is a robotic vacuum cleaner, right? Like, and it got like super popular during COVID time, but it existed like 10-15 years back as well. So it would automatically go map the area of your house and saves that map, and after that it's able to go and like go to different rooms and clean it autonomously without any human help. And whenever it needs, whenever it goes low on charge, it will go automatically to a docking place, charge itself, and does that. So even if you're not in home, you can pre-program it to like clean at certain places and so on, certain times and so on, right? So that's a great example of a robot that does just one job, which is to clean the house, but does it really, really well. So that's a personal inspiration for a lot of us at Ati. So we should do one thing, which is to move material within factories, but do it really, really well. So that's what we want to do. Like, so some of these robotic companies, we see that they attack a very complex problem, like a humanoid, right? It should fold your clothes, it should do laundry, it should cook, and it should clean, it should do a lot of things. And that's a very hard problem because you're now competing with human intelligence. But if you're like just training your AI models to do like specific problems, it's much easier to do that. So that's an approach that has largely worked, I would say. And I think we are able to understand how to do that. And the way we expanded was in adjacent fields. So now you saw that it's like pulling trolleys. Then we said we'll do bins. Then we said we'll do pallets. Then we said we'll do platforms where you can take like bike chassis or even a small three-wheeler chassis and so on. So ultimately, it's material movement. The robots, what it does, it moves from one portion of the factory, or one location of the factory, another location. It has to move material. That's what we decided to do. So that's about what Ati does. And I should tell a little bit about my personal journey. I have no robotics training. I had none before I came to this company. My training was all in wireless communications. So we used to make like 4G base stations at Motorola, then Nokia, then another startup. And I was just tired of it. I wanted to do something else. And at that time, Ati was starting like 7 years back. We were talking about it, and I was exploring an opportunity with their founding team. And they said, like, none of us know about robotics, and we're all going to learn this together. And this leads to my first point for all of you. I think you need to have this kind of healthy curiosity to try and explore newer fields. What is hot right now is probably not going to be hot in 5 years' time. So don't be in your comfort zones. And you're all entered in this era of lifelong learners. I mean, it doesn't stop with Polaris after 2 years. You need to keep learning newer things month on month, year on year, right? Like whatever the form of consumption, it could be blogs, it could be podcasts, it could be online classes. You have like all kinds of resources now. So this kind of a curiosity and lifelong learning is like super helpful. And my mentor, he had a rule that every 5 years he'll change his field. So he did edtech, he did biotech, he did robotics, and he did a hardware startup. So over like 20 years, he did like completely 4 different things. And that's great. I mean, of course, there are specialists who have been doing the same thing for like 15-20 years, and that's good too. You have to figure out your path at some level. But what should not stop is like you need to keep reading. You need to keep learning new things. So that's helped out, and for me, and I'm sure that will help out for you as well.
Naveen sir, over the last 5 years, how have you seen the field of robotics change and evolve?
So 7 years back when we started Ati, there were not enough folks who could work on robotics, just like us, right? Like a bunch of us who had never done robotics before we started this company. But now that's changed quite a bit more. You have like a huge talent pool in India. A lot of people do ROS, A lot of people have done a fair bit of robotics projects in their colleges. Some of them have started at even high school level. You see more robotics hackathons. You see more robotics challenges that are happening at school levels and college levels. So the exposure is very high. It's not difficult to hire people anymore. So that is like a huge trend that you see. The other thing that you see is that in terms of investments, in terms of customer adoption, it's not new anymore, right? Like post-COVID, there is a lot of people who want to see how you can progressively invest in robotics and automation, and how can you kind of reduce at some level the grunt work that humans do. I mean, that's like a conscious choice. You don't want people to be pushing 1 or 2 tons of stuff in really difficult environments, right? Like in robotics, they say, where are you ripe for robotics? DDD, dirty, dangerous, and difficult. You don't want those things to be done by human beings. So there is a lot of emphasis on from upper management to get rid of such jobs and use robots instead. So that is something, in terms of attitudes, things are changing, and in terms of people who want to work in these jobs, that's also been changing.
You mentioned that since the field has matured and there's a lot of exposure in terms of there are communities around this, there are hackathons, there are events. So for some of the kids who essentially want to start thinking and explore whether they like the field or not, what are some of the good communities in the country, or some where can they go on the internet and find?
Where's the action?
Yeah, where's the
action? So yearly there are 2 ROSCons. If you're interested in, that's a great way to hook up with other people. So usually all the ROSCons come up with a hackathon as well. I don't know if you guys know about ROS. Yeah. So we don't do ROS. We do proprietary robotic stack. It's a conscious choice that we took. But
what is ROS?
Yeah, I'm just going to come to it. So ROS is Robot Operation System. Okay, and that's something that it's a misnomer. It's not quite an operating system, but it's got this framework that you can easily plug and play into robots, right? So what are the just to back up a little? How does a robot work? Any robot. It can be a drone. It can be a mobile robot. It can be an underwater robot. Whatever it is. It's trying to answer 3 questions in a loop. Where am I? Where should I go? What should I do? So every question is an algorithm of some sort. And you need to code it up, and you get the answer, you go to the next question. And you keep doing that, it'll finish its job. Okay, that's about it. All of robotics. So, and there is a family of algorithms, right? Like it depends on whether you're making an underwater robot to clean, I don't know, the lakes of Bangalore. I hope some of you do that. Or maybe you have like a manual scavenging robot. Or you do like a arm which will segregate waste. All kinds of things, right? Like Jensen Huang famously said that everything that's going to move will become robotic. It's only a matter of time. It's going to happen. So depending on the robot that you're building, the algorithms are going to change. The programs are going to change. And there are lots of people who have been working on specialized robots, right? So ROS is the community which has enabled roboticists around the world to pull in their algorithms for these different class of problems, and you can plug and play whatever you feel like. So there's probably an interesting group in Germany or Toronto, and they have done a robot that can figure out a particular phenotype. I mean, an agricultural robot. If it is a weed or not, can I pick this fruit which is ripe or not? There is a very big agricultural robotics group in Germany. So they could contribute such algorithms. And you can actually, once it's a ROS package, you can just pull that in and you can load it on your robot and you can try out the same things. So it's basically one of the bigger open source robotic algorithms that are out there. It's in a common framework. So once you pull that code in, you can use your own robots to try those algorithms out, right? Your base robot is different, right? Like It's got to have motors and wheels and whatnot to make it move. That's your problem. That is something that the ROS guys will not help you with. But the logic to make it move, the logic to make it observe an environment and understand where it is. So there you will have plenty of help from the ROS community. And there is this ROSCon. There is last couple of years, there is a very active ROS community now in India. Just to repeat, ROS stands for Robot Operation System. And that's a great way for students to learn. So the last couple of years, this ROSCon happens. There is one going to happen in next few months in Indian Institute of Science. You should just look it up, and like every 6 months, it keeps happening. So you can go meet up. You can understand what kind of talks are there. I mean, these events are like almost free admission-wise. So that's a good way to get started. Other things is like, I mean, you have to just, I mean, imagination is the only barrier, right? Like, what is the problem that you want to solve? Go ahead and make a design. Some of you are good at electronics, some of you are good at computers, some of you are good at mechanical design. So you just have to partner up, come up with this idea, brainstorm, look for mentors who will critique these ideas. Not that you probably need. All mentors could probably tell us that spot some obvious issues. And the way robotics works is that your first robot is probably going to fail. You're not going to do the work. So reiterate, do it again, understand what's happening, take that feedback into the next design, keep doing that, and you will make really interesting products.
That's super interesting and super helpful. Naveen sir, no, the session is not finished yet.
Not yet, I suppose.
The one very interesting thing I picked from whatever I heard so far is that 7 years back you actually started this from scratch, right? And not just about the company, but your personal learning and exposure to the field would be like you started at a senior age. You started at from absolutely zero,
absolutely.
right? Which is a very hard thing. But during that time, they would be, and between those 7 years back and 7 years today, like the one thing that we have moved very forward is the availability of resources online, right?
Sure.
Like the amount of information that is present out there on the internet is so much more than what was present 7 years back.
Actually, the problem right now is not lack of information, it's too much information.
Exactly. And that is what I was coming to. So for these kids, basically who when they go back to their systems and start searching on the internet, instead of scarcity, they will be overburdened with abundance.
Absolutely.
So what are some of very good and trusted resources that you found very useful when you were starting to learn about robotics in general, and like as you grew, like even verticalized, specialized?
So, see, that's a good question. So it depends on at what level you want to get into robotics, right? Like, so robotics can be deeply mathematical, and if you want to make new algorithms, that's a completely different ball game, right? Like, and then you want to look for academic sites, and there are like some fantastic resources out of University of Bonn. There are some great resources out of Northwestern, UPenn, CMU, Stanford. These are all resources available for free. There is nothing that you have to pay for, right? Obviously, if you were looking for certifications, you want to go to Coursera or Udemy too. Like if you want to take a basic ROS course, there's a reasonably good ROS course in Udemy. So all these resources are available, but at what level you want to practice is your own. So if you want to build new algorithms, then you want to take some math classes, you want to take some physics classes, and you want to understand those kind of things. But if you want to practice robotics, then you can just jump into ROS and you understand you can be more hands-on, and you just want to build things, and you want to take things that other people have worked on and do a little bit of tweaks, bring the inner engineer in you, and then you can get going. That also works. So, but you're again going back, some of the things that I would advise is that don't meander. There are lots of resources. There'll be this famous example where you take a course and then you find that some material is difficult, then you take another course and then you find that not understand that, you go somewhere else, and it's like a cyclic loop. So you don't want to do that. Start with basics and then teach yourself that this is enough. and then let me go back and try some of these things in practice, and then we go like that. You'll have to calibrate yourself. You shouldn't spend all your time watching YouTube videos. That doesn't help.
And the robotics engineers that you would hire in Ati Motors, most of those, so I'm asking this from a point of view of if somebody wants to make a career, let's say 2-3 years
Sure.
or 4 years down the line in this field, like the kind of engineers that you hire, are they already very proficient
No.
in something, or they learn on the go as long as they have an acumen, curiosity, and an interest in problem solving? Do you still hire people who are not extremely acquainted with robotics and then they grow inside the company as you go forward?
So nowadays because we have like really good choices, we kind of expect that they've done some robots before. But I remember the first hire I had was like we got really deep into. He didn't have a college degree. He had dropped out of 12th, and we had a very deep conversation of how he services his own bike. That's the only thing that I wanted to find out. How do you service his own bike? Like if the spark plug goes off, what does he do? If the headlight doesn't work, like what does he do? So this is the kind of this boy. He would never take his bike to a mechanic, and I really enjoyed that kind of hands-onness in him. Right, like he was deeply interested in learning about the machine and servicing it himself. So that's something that was like highly appreciated. So that's the kind of person that you want. Like you shouldn't be afraid to tear down this TV. Okay, I don't know.
Not this TV,
Not
but
this TV. If something doesn't work, you shouldn't. I mean, you should try and fix it yourself. So that's exactly what we would be looking for early on. Now, of course, we are asking for people, have you built a robot before? And we have become a little bit more snobbish than before. Yeah.
Oh, that's super helpful. In fact, we'll open it for a couple of questions from students because I can see a lot of interested faces.
So one thing is that we've not stopped here. We work with there is like a drone project that we do internally. That is again for inventory tracking. So one of the things that you would do is that some of the bigger supermarkets that happens, and that is true with factories as well, they'll have an inventory audit day. So if there's a tire industry or something, right? Like they wouldn't know, they need to go through the entire stores, entire plant to find out what is sitting where. And that's something that ground robots will not be able to do. You need to fly. So this is something that we are working with a few partners to do this, right? So what I'm trying to tell is that I wouldn't do an aerial robot just for the heck of it. It should have a purpose, and it should have like real value to an end customer. Right, like in that sense, all the robots that we do have like tangible business purpose to it, and that's the way we've been doing it at Ati. If I'm at Indian Institute of Science or something, then we can do like robots for fun. But that's the difference that you would see in like in a commercial setting. Everything's got to have a purpose. It's something that has to have like an end game in terms of a product. And what's a product? A product has to satisfy someone's problem, and that someone has to pay money for it. So the drone itself is the easy part. So we don't do autonomous drones. We do tethered drones. Tethered drones are like the power and the communications cable come from the robot. So the robot will take the drone to some stage, and then the drone will hover, finish a rack, and then come back and charge again, and then keep doing that. So if you look at normal drones, right, like especially quadcopters, which is the most common category of hobby drones, it's basically 4 motors, and you use the 4 motors to lift, move straight, or move left. So with that, there are only actually 4 motors, but you need to do 6 degrees, rho, theta, phi, and x, y, z. So it's like an under-actuated system that they do. Right? So what you see is that typically it will last only 20 to 30 minutes of runtime. I don't know if any of your hobby droners, you have like, you've worked on tried flying a DJI drone. So it'll get like 20 minutes. They'll give you an extra battery and you'll get probably another 20 minutes. That's about it. So that will not work in an industrial setting. That's why we went for a tethered drone. So the power is always continuous to these drones. You don't have to worry about it. Technology, I don't know, but I read a lot of business books now. So there is the Peter Thiel's book, which I enjoyed, which is good, 0 to 1. And Peter Thiel.
It's called PETER.
Thiel.
No, not thief. Peter was not a thief. It was
Thiel.
THIEL.
THIEL. That's a famous book. A book that I recently read, which I quite liked, was Satya Nadala's book. It's called Hit Refresh. Back in the day when I was as young as you, we were all asked to read Lee Iacocca's book. How he turned around Ford and how he rebuilt Chrysler. Lee Iacocca. LEEIACCA, maybe. I mean, look up Lee Iacocca. He's the ex-Ford and Chrysler president. So, yeah. So, I mean, there's one estimate that if you have to read all the books that have been written, you have to be born in, like 120 lifetimes or something. So that many books are there. So it's very hard to tell anything. Yeah. Okay. No, I don't think there are lots of things that humans can do which robots cannot do right now. Probably cannot do it in the next 10 years also. For instance, people say how robots do really, really well playing the game of Go. Right? Like you heard of this company called Google DeepMind. So they've been training AI models for very, very specific tasks. So chess is conquered like 10 years back. I mean, Magnus Carlsen probably cannot stand the alpha chess version that DeepMind have, right? Like they have gone there. But Go is an incredibly complex game. And they've beaten the human player like resoundingly. But my opinion is AlphaGo can do Go well, but unlike us, it cannot talk about politics, it can't play cricket, it can't paint, it can't cook. So what it has done really well is do well in one sport, which is Go. It's a complex game and they've done very well, but I don't think it can encompass the complexity that we have, right? Like even if you have a self-driving car, I drove my car and I came back, right? Like, but can it also have a conversation with you? Can it also go back and cook? Can it also draw? Can it have a opinion on different topics? That's not going to happen in a while. So that's what they call as AGI, right? Like artificial general intelligence. I don't think it's near, but it feels like you're going towards that. Especially some of the answers that ChatGPT gives, you're like, if this is not intelligence, what is? Right. So that is there. But I think still physical work, especially your fingers, these are extremely dexterous. Very, very hard for a robot to replicate. Brute work, maybe. You can do a spot welding. You can do painting. But when there is something to do with like a smartphone sub-assembly, I don't know if any of you have seen videos of that. It's so nimble. The workers who put so many of these components inside like one of our smartphones, right? So it's not something that a robot can do that easily. So for some time we are safe from robots. That's my opinion. Real life robotics is a little bit more, I would say, boring. I mean, people will not agree with it if I say that, because you want to make an identical copy of one robot into 1,000. right? So that to some extent we have to piggyback on best manufacturing practices, and you also need to get into these zones of compliance and standards and certifications and so on. So why would an Arduino not work in a robot like this? The problem is the G-force of vibrations. These places are very, very hostile. So there will be like speed bumps, there will be cracks, there will be oil slicks, there will be water on the floor and things like that. So the robots have to go through these kind of things. And so the shock that the electronic systems go through are like 10 times or 100 times more than what you would normally do while you're checking out your personal projects. So that's the hardening that we have to do. So the wiring is different, the processors are different, they're rated for these kind of hostile conditions. So every component, we have like 400 different BOM components that go into a robot. Every component has to be rated for 0 to 50 degree operation. If they don't, it will, for guaranteed, it's going to fail on the field. And you have to make your robots dust proof, rain proof, splash proof. Some of them will say that you need to make them spill proof, meaning that if like liquid fills on them, it's the cover needs to be resistant to that. So that's the kind of hardening that you have to do, and that comes with time. And honestly, some of it comes with failures. You go to a tire factory, it's filled with carbon soot and sulfur, and I wouldn't be able to stand there for 10-15 minutes. And then you realize that there is a particular component that fails here often. You have to go back to your drawing board, make it again, understand why it's failing, make it again, put it in, see. So this kind of observe, iterate, deploy. So that's a cycle that you will do even as ML engineers. You should not shy away from that hard work that you have to do. That's a great question. This is a pet topic for me. I think what is required is that robotics companies tend to guzzle a lot of money upfront, but later on it really scales well. For instance, we did 1 robot in the first 5 years, and then we did 7 robots in the last 2 years. So you get like the learning curve is huge. And a lot of our software stack, the hardware stack is identical across the 7. But the first thing that we had to make, we took really, really long. And some of the investors are not very patient with that. And the starting money, the seed money that you need is usually 5 times more than like a typical software startup. So both these factors usually rig the game against robotic startups, but things are changing. And that's it, like we share a common investor and they've been nothing but fantastic. So things are changing, I would say. And what we need is like more success stories. So they will pay. Sorry? The economic factor is just that, right? Like it's, you need more money to start with because the kind of investments that you need to buy sensors and the testing labs that you make are all capex. And it's not counting towards anything for the first few years till you make a product and someone buys it and pays for it, right? And the other thing is that, as he was talking about, you need to harden your product, and that will need reps and iterations. Improve the product. It has to be made rugged to work across different environments, right? Like so that will also take a little bit of time. So, but once you've gotten the formula, repeating it is easy, and you can cruise through it. It's not too difficult to replicate it, Control-C, Control-V it into many more robots.
I think that's for today. Thanks a lot, Naveen sir. I think a lot of people would have learned